meta-analysis to draw forest plot and funnel plot in SPSS when the outcome of the studies are binary. Binary outcome is an outcome or a variable that have only two levels in it. So it's binomial, either yes or no, live or dead. And the estimate for the effect size is the odds ratio. So what is a meta-analysis? Meta-analysis consists of two parts. The first part is systematic review, literature search and reviewing and collecting publications that addresses a specific medical or scientific question. Those studies are independent, but they all address the exact question, or they have the exact or similar objective for that study. So the meta-analysis is the second part. So the first part is literature review or systematic review. The second part is meta-analysis, which is a statistical method that combines results from several independent studies and then give a summary for these results. So it does provide it provides a precise estimate of the effect size for specific intervention or exposure or treatment compared to a control by pooling or producing an overall effect size. So the meta-analysis will analyze the data from a previous study that already been done and the results are available. The meta-analysis will combine the data to try to identify patterns and draw a final conclusion based on these multiple studies. The meta-analysis also will measure the degree of variability between these study results by generating confidence interval, performing tests for heterogeneity of the results. So heterogeneity test will measure the variability between the result from multiple studies, and this is performed in meta-analysis. So if the value for I squared is equal to 0, then this indicates no heterogeneity. A value of 100% indicates maximum heterogeneity among the studies. The meta-analysis also will generate an outcome by drawing a forest plot. So forest plot is a graph that presenting the result of meta-analysis, and that graph is consist of three sections. The first section is descriptive statistics, showing the description for each studies included in the analysis, the number of participants, the groups in the studies, experimental compared to control or a reference, the percentage of weight, the 95% confidence interval, and a p-value. The second section is a diagrammatic representation of the summary for these studies by plotting effect size. And the third section, which is a statistical analysis that produces the overall estimate effect size, and a significant value is produced, p-value, and also a test for homogeneity and an I squared generated. So the forest plot will display the magnitude and the direction of the treatment effects compared or relative to control across the different studies, and it will also identify sources of heterogeneity or inconsistency in the overall results. The meta-analysis also will generate a funnel plot. A funnel plot is a graph that will display the effect size for each individual study plotted against the standard error or sample size. So the funnel plot graph will assess the publication bias. Here in this SPSS data view, I have a data that has been extracted from 12 studies, as shown here with the first column, a study ID or the first variable. There are 12 studies, and in each study the objective of each study was to look at the effect of using a novel drug to treat a condition. So here we have two groups of data for each study, treatment group and a control group, and the treatment group has two variables in it. The first variable is whether the treatment was successful or whether the treatment was not successful, failed. So for each group, individual or participant were recruited and given a drug and then followed up, and then the number of participants who had recovered completely from the condition were recorded as successful, and those who failed are counted. The second group is the control group or the placebo. This group have not been given any treatment and the participants are used for referencing. So the control group have two variables in it. The first variable measures the number of individuals that who have recovered from the disease, and they are given called a success, and those who have recovered from the condition are counted and placed in the variable C success, control success, and those who did not recover without any intervention, they are recorded here in this variable for control failure. So there are two groups, a group of intervention that given a drug and a group that are not given a drug, and then a follow-up period to look out if and observe whether the condition has been cured. And the objective is to look at the efficacy, whether this drug can cure the condition. So here the data are binary. So the outcome from each study is binary or binomial. So there are two levels or two categories in it. The treatment groups either successful or failed, and the control group either successful or failed. This data are binary. So each group has two levels in it, either successful or failure for the intervention, and for the control both groups are binary. And the way to combine and add all the studies together and the result from these studies to do a meta-analysis is to use the estimate effect size, which is the odds ratio, as these data or the outcomes from these studies are binary. And the way to do binary meta-analysis is to click on analyze and then click on meta-analysis here, and then since the outcome is binary, then select the binary outcome, and since the data are raw, there is no pre-calculated effect size, we'll stick with the raw data. Click on that option. A new window here will pop up, and as shown here, there are two sections for doing binary meta-analysis: treatment group, intervention group, exposure group, and a control group or a reference group. And for each group there are two levels or two categories: success, failure, success, failure. So this is a binary outcome or binary data, or sometimes it's called dichotomous. And the way to fill that is select the study ID and move it to this section, and for the treatment move it to this box, and for the failure, the success in this one and the failure in this one, and for the control, see success, move it to the control group, and the failure for the failure section. The effect size that will be measured here is the log odds ratio. There are several options. We could go for bit to log odds ratio, or risk ratio, or risk difference. For this video, we'll stick with the effect size for odds ratio. And the model will be used here. We'll go for the fixed effect Mantel-Haenszel method. And if we click on criteria here, no changes will be performed. And if we select the options for analyze, these options can be done when there is subgrouping analysis, or the meta-analysis require sectioning of the studies into groups and then perform independent separate meta-analysis, but we'll not do this in this occasion. And if we click on contrast, no changes here. And if we click on bias, we'll leave this aside now. And for printing the output from a binary meta-analysis, tick on the test of homogeneity, heterogeneity measures, and effect size individual study, display exponential statistic or statistics. Click on continue. For save, not going to do any changes here. For the plots, I am interested in generating two important plots. The first plot is the forest plot, and then in the first plot I want to display the effect size, the standard error, the confidence interval limit, the p-value or limits, the weight, and display the exponential form. And for annotation, tick on homogeneity, heterogeneity test, and for reference lines, tick on overall effect size, null effect size, and then so this section is for the forest plot. And if we are interested in also simultaneously generating a funnel plot for publication bias, tick on the funnel plot and then move the study ID into this section. Click on continue. Now if we click on OK, an SPSS will generate an output as shown here. The meta-analysis summaries shows the data are in raw and the outcome is binary, and the effect size measures or estimate is the log odds ratio, and the model is selected fixed effects, and the weight is based on Mantel-Haenszel method. Moving to this section here, effect size estimate, the effect size calculated is 2.77 and the p-value is less than 0.05. So there is a significant difference between the treatment group and the control. for overall all the studies. So this effect size is a pooled or overall effect size for the 12 studies, or the odds ratio for the 12 studies, and this value is significant, and the 95% confidence interval includes this effect size in it. This gives a double confirmation that the observation or the findings or the overall effect size is significant. And here also given an exponential effect size with its 95% confidence interval. For this section, which is the test of homogeneity based on chi-square and Q statistics, and the degree of freedom is given, and a p-value is significant or significance, or the p-value is given here. So this test reflects the degree of heterogeneity between studies, and for the homogeneity test, the higher the p-value, or the p-value greater than 0.05, that indicate there is less heterogeneity and more homogeneity among the studies. So these 12 studies shows that there is less heterogeneity among them. If we look at the following section here, I squared is produced, which is presented in a percentage, and the percent is equal to 0, which indicate that there is no heterogeneity among the studies. The next most important diagram is the forest plot. So this plot is representing the forest plot, and there are 3 sections in it. The first section here, which is descriptive statistics. The second section is diagrammatic representation, and the third section here is the statistical analysis. So looking at the first part, as shown here, the ID for each study from 1 to 12, an odd ratio is generated for each individual study, as shown here. As shown here, the OR is given in exponential form, and to revert that to non-exponential, then click again on meta-analysis, binary, and in the plot section untick display exponential or exponentiated form, and click on continue and click on OK. And as shown here, the stats descriptive here is given in the log OR, and as shown from this output, each individual study has its own log odds ratio, and the standard error is generated, and 95% confidence interval for lower and upper, and a p-value. So there are 2 layers of confirming the significance of these observations that compare the association between treatment and recovery from the disease compared, or the condition compared to the control or reference group. As shown here, there is a significant association between taking the drug and recovery from the condition, and also a weighted value is given for each study and a percentage of the weight study, and that reflects the influence of the sample size on the analysis. This is for the first section. Moving to the second section, and before even moving to the second section, here there is a value generated called overall estimate effect size, which is the odd ratio or odds ratio, which is equal to 2.77, and standard error is generated, and upper and lower for 95% confidence interval, and a p-value. So this is the pooled or overall odds ratio from all the 12 studies, and it shows that there is a significant association between taking the drug and recovery from the condition compared to the reference group. Looking at the second section here, which is the diagrammatic representation of the effect size for each individual study and the overall effect size. And if we look at the legend here, we notice that the square symbol here represent effect size for each study. So each study has its own effect size. The diamond here is the overall or pooled effect size, and for each study there is a horizontal line which reflects the confidence interval. So this is the estimate effect size for each study, and the horizontal line is the confidence interval, a 95% confidence interval with a lower and upper limits or value. And for also the overall estimate effect size, there is a horizontal line that represents the 95% confidence interval. The red line here, the horizontal dashed red line, represent the overall effect size, which is the overall odds ratio, which is 2.77. So this graphs here is a representation of the descriptive statistical descriptive for each studies and for the overall effect size from these 12 studies. And as shown here at the bottom, the scale is start from 1 and onward, and the size for each square here reflects the percentage or weight percentage. So larger samples or larger study sample size have larger squares. As if we look here at the study number 10, we can see that the sample size is higher as measured by the weight, percentage of weight. So smaller squares means the sample size is small, and larger square means the represent the larger sample size. And the overall effect size or the overall odds ratio in this case is the green diamond, and it is on the scale of 2.77. This is the second section for the forest plot. The third section for the forest plot is the statistical analysis. As shown here, the model is fixed effect model or effects model, and heterogeneity test, as shown here, the I squared is 0. So that's reflect that there is no heterogeneity, and the results from all these 12 studies are homogeneous, and as given here by a p-value greater than 0.05, which means that there is homogeneity among the studies. And for the test of overall effect size, which is the OR, odds ratio, that is standardized through Z scale, p-value is less than 0.05. So the overall conclusion from this forest plots shows that for all these 12 studies that we're looking at and investigating one objective, which is the effect of this drug in treating the condition by having two groups, one intervention group and one reference group, there is a higher association of success for recovery from the condition when the treatment is added or given to the participant compared to a reference group, and this association is significant. Moving to the last graph, which is the funnel plot. A funnel plot will display whether there is a publication bias, and it has on the y-axis the standard errors, and on the x-axis is the log of odds ratio. So the odds ratio for each study is given here as numbered from study number 1 to study number 12. And the line here in the middle represent the pooled or overall effect size, which is the odd ratio, overall odd ratio of 2.77. This funnel shaped graph, so the distribution of these studies should be equal on the above and the lower, which indicates if they are equal or approximately equal, no bias. However, if they are unequal, then they suggest a bias. And as we can see here, we have 1, 2, 3, 4, 5, 6, 7 on the above the pooled odds ratio, and there are 1, 2, 3, 4, 5 below. So this plot will determine whether there is a bias in the publication, and then this also need to be backed up by Eager's regression analysis. So this is the way to do meta-analysis for binary outcome in SPSS and plot, funnel plot and forest plot.